All right, so today's lesson's on conditional statements. So first thing here is we have an example of a conditional statement. It says, if you study, then you will get a better grade. All right, and a conditional statement is really any statement that can be written in an if-then format. All right, so if-then format. Now, there's two parts, the hypothesis, which is really the if section. So in this case, it's you study. All right, and the conclusion, which is really the then portion. All right, and the conclusion on this one is you will get a better grade. All right, so the two connected form the conditional statement, but there are the two components, both the hypothesis and the conclusion. Now notice with each of those, I did not write the if and the then with the actual hypothesis and conclusion. All right, so if we go ahead and we take a look through, sometimes we're going to find that these are written without an if-then, and we may have to add those in, and we'll see that in some of the examples over on the right. So looking at the first example, it says, write each statement as conditionals, identify the hypothesis and conclusion. So this first one, it says, all animal trainers are strong. So the conditional would be, if a person is an animal trainer, comma, then they are strong. All right, and this would leave us with a hypothesis that is a person is an animal trainer, and a conclusion that they are strong. All right, another example would be an angle of 40 degrees is acute. So the conditional is if an angle is 40 degrees, then it is acute. All right, so the hypothesis would be angle is 40. Conclusion would be acute. All right, now that one is definitely a true conditional statement because if an angle is 40 degrees, it is certain that it is an acute angle. All right, then the third one on this section says, get a free t-shirt for filling out this survey. Now, you really want to be careful in some situations because it does appear almost backwards. You want to think about cause and effect. So in this, getting the free t-shirt doesn't cause you to fill out the survey. It's filling out the survey that causes you to get a free t-shirt. So the conditional is going to be if I fill out the survey, then I get a free shirt. So it works in this case, the writing of it, you want to think cause and effect. So that second part is actually a hypothesis and the first part is the conclusion of the original statement. So the hypothesis for our conditional is I fill out the survey, and then our conclusion is get a free t-shirt. All right, so when we look at conditional statements, you're really looking if-then format. The biggest thing you want to watch out for is any time when the cause and effect seems mixed up in the order that the sentence is written. And you always want to look for that if part being the cause, and then the then part being what happens because of that cause. All right, now when we look at this, the truth value of a statement is always either true or false. All right, those are the two options. All right. All right, and we can also say that the hypothesis and the conclusion, all right, of a conditional statement, as well as the conditional statement, can also be true or false. All right, and this is where in a logic class you'd move into truth tables. And the important thing to remember is there's really only one way that a conditional statement can be false, and that is if the hypothesis is true, all right, and it implies that the conclusion is false. All right, this would be the only false situation. All right, so if the hypothesis is false, we can't say anything about the conclusion. It might be true, it might not be. But if the hypothesis is true, then the conclusion has to be true for the statement to be true. All right, so in example 2 over here, it says, if Matthew rests for 10 days, then his ankle will heal. All right, so the first statement says Matthew rests for 10 days. That's a true hypothesis. All right, and he still has a hurt ankle. So that is a false conclusion. All right, so this one overall has to be false. All right, if I go to B, it says Matthew rests for 3 days. All right, so that is a false hypothesis. All right, we haven't hit the rest for 10 days. At this point, you can automatically say that this is a true conditional statement. All right, the whole statement, the result is true because we haven't met the condition of the hypothesis, so we can't say anything about the conclusion yet. All right, the next one says Matthew rests for 10 days. All right, so the hypothesis is true, and he does not have a hurt ankle anymore, so the conclusion is true. All right, so true implies true. This is another true situation. And then the last one said Matthew rests for 7 days, which is false, and he does not have a hurt ankle anymore, so the conclusion is true. All right, but in this case, we can't say anything because if the hypothesis isn't met, it is always going to be a true statement. All right, because we can't say that it broke what the conditional statement implied. All right, so whether it's false, false, or false, true, we consider those from a logic standpoint to be true statements. The only false statement is if we have a true hypothesis and a false conclusion. All right, now with each conditional statement, there are several ways that you can rewrite it. Some are mathematically equivalent and logically equivalent, and some are not. So the first way that we can rewrite a conditional statement is the converse. All right, so if the original conditional statement was an if-then statement where we had if P, then Q. And a lot of times you'll see this notation. All right, that's really equivalent to if P happens, then Q happens. All right, you'll see it written like that. The converse simply switches the order. So instead of P implies Q, it's Q implies P, all right, which is if Q, then P. All right. Now, the converse is not necessarily true if the original function is true. It might be. If it is, we have a biconditional, which we talked about in the first section. But if it's not, that's okay. There's no guarantee that it will be. So in this first one, it says adjacent angles have a common side. So normally that would be if adjacent, then common side. All right, so the converse would be if angles have a common side, then they are adjacent. All right, and this is actually false, because if we look at the big angle here, all right, I'll call it A, B, C, and then I come in with blue, and I draw this other angle here, C, B, E. All right, the blue angle and the red angle aren't adjacent because they share common interior points. All right. The next one says, if a shape is a square, then it is a rectangle. All right, which is a true statement. The converse would be if a shape is a rectangle, then it is a square. All right, and this would be false as well because we could draw all kinds of rectangles, like a 2 by 5 rectangle. That's definitely not a square. All right, so again, the converse is a way to rewrite a conditional statement, but you aren't guaranteed that it has the same truth value as the original conditional. Now, there's a couple other ways to rewrite these, but to do those, we need something called negation of a statement. All right, so that's the complete opposite. All right, so if one statement says you love pizza, the complete opposite would be you don't love pizza. All right, don't flip to the extreme opposite, which is hate, right? Because you can't guarantee that. It's either I love pizza or I don't love pizza, not I love pizza or I hate it. All right, so when we think about negating, it is the complete opposite. It covers all the other options. So the opposite of love pizza would be don't love pizza. All right, so really we're going to just negate it. And if the original statement was like P, if we use that abbreviation for the hypothesis, then the negation we write as a little like squiggle, P, which is not P. All right, so this one says 3 points are collinear. The negation would be 3 points are not collinear. All right, and the next one's 2 lines intersect. The negation would be 2 lines do not intersect. All right, now these negations allow us to write the other 2 formats. All right, so the inverse, all right, if we go the conditional is P implies Q, then the inverse would be not P implies not Q. All right, and this doesn't necessarily have the same truth value as well. So in this one, it asks us to rewrite these. So this first one says, if you live in Texas, so negating that would be if you do not live in Texas. All right, the original statement was then you live in the United States. All right, so this one, negating that would be then you do not live in the U.S. All right, which again is a false statement. The next one, all quadrilaterals have 4 sides. So if quadrilateral, then 4 sides is the original conditional. So the inverse, all right, would be if it's not a quadrilateral, then it does not have 4 sides. All right, so we're basically just negating the hypothesis and the conclusion. The last one here is the contrapositive. So the contrapositive takes a P implies Q, and this does both the inverse and the converse. So this negates both of them and switches the order. So we'd have not Q implies not P. All right, now the beauty of this is the one logically equivalent statement of them all. All right, so if we look at the example, it says if 2 angles have the sum of 180, then they are supplementary. So we're going to flip and negate. So if 2 angles are not supplementary, then they do not have a sum of 180 degrees. All right, and this is the one logical equivalent to the original conditional statement. The inverse and converse are not necessarily equivalent, but the contrapositive always is. It has the same truth value as the original statement. So that takes us through the different types. Tonight's homework is really going to be a lot of practice of identify hypothesis, conclusion, and then rewrite each of these forms of a conditional statement. All right, thanks.